Okay. A minute or two. There goes. So Manish Gulati, many of you, of course, must have heard of him earlier also. He's been known. He's an alumni of Sept, Ahmedabad. Started his career in 2000. Is a visualizer of events, exhibition industry. He's moved from there. Is there an echo? Excuse me. Is there an echo? Yeah. Request everybody to just switch off their mics for the time being. Yeah. So Manish, manifestation of fluid architecture, MOFA, under his leadership, has won multiple international, national design awards, special mentions, and competitions. So MOFA specializes in design of public spaces and institutional buildings, and their works range from large stadiums to private homes, humanitarian research projects, and public art installations. Each project undertaken by the firm goes through exhaustive research and interactions to eventually derive intuitive spaces. Manish believes that a sustainable ideology can never be an isolated entity and should be part of an all-inclusive process of design. So, and his forte and driving passion. This I must say, Manish is very, very passionate and very, very finicky about many things. So till date remains design and innovation, and he believes through design we can provide solutions to any problem in the world, and that's like a big thing to have. And I think he truly believes in it. So he doesn't mind telling anybody on their face what he believes in. So way to go, Manish. So I'll introduce Anuj here. Anuj Mittal, Chief Operating Officer, MOFA Studio. Anuj Mittal is an architect and a computational designer. He focuses on the algorithm modeling of complexes, geometries, data-driven design, and digital fabrication. He also heads the computational team where he is currently researching on developing mass customizable fabrication methodologies for prefab construction. He holds a master's degree in advanced architecture from IAAC, Institute of Advanced Architecture of Catalonia, Barcelona, and a bachelor's from SPA, New Delhi. And Anuj, you'll be very happy to hear the session before this, we had Rajiv Lunkar, and he kind of comes in from was talking about craft and traditional knowledge systems and the emphasis that our traditional knowledge system gives to geometry. And I think this was something that we guys were having as a discussion between ourselves, and we were discussing what is it that we need to bring to the table over here. And the emphasis to what rigor. Manish will be very happy with that word too, and geometry. So all over to you both. Thank you, and thank you for coming in.
Thank you so much. Thank you for that lovely long introduction. We should shorten that probably next time and spend more time showing the work. So I'm going to take over the screen and start with the presentation. Just let me know if the screen is visible.
Yes.
All right.
It's visible.
So I'm going to start with the point that you made, which Rajiv had made already. And suddenly my computer decides to act up. Anyways. All right then. So I'll continue the trail of what Rajiv was talking about, probably about craftsmanship. And this is the starting point for us as well. As you can see here, we've put together just 3 projects, 3 out of many projects done over the centuries since the time we have been there. Chand Baoli in Rajasthan, which was done in 880, around 880. It started then, of course, continued, so we don't have the dates exactly. St. Peter's Dome, which is a double dome, an inside and an outside, to 2 different geometries. In 1547, that is when it was conceived by Michelangelo. And Nazir ul-Mulk Mosque in Iran in 1876, and there are many such mosques in Iran, which take over the fractal geometry and put together this very complex construction without the use of any computers or anything in those times. So this is what we were doing. This is exactly what the kind of architecture we were practicing. And then we did this in 1929, which turned into this. And this started an entirely new revolution, something called we call modernism, something that we are so adept at using. And then this happened. A lot of perversions of modernism and the modernist cube happened over the years. This is one of the famous ones that made it to the news in 2001 by Ashton Raggett in Melbourne, where he talks about the black Villa Savoy, or it's also known as the evil Villa Savoy, because he takes the same model of Villa Savoy and he puts cladding all over it. He puts these modern materials all over it. So the point that one is making is that Corbusier, from that point onwards, where we were talking about multiple craftsmanship, complex geometries, and various things, he reduced it to 5 principles of construction. And over a period of time, these unfortunately became the principles of construction of the modern world. It made sense somehow during that time in 1929, post First World War and then post Second World War. The world had to be rebuilt really, really fast, and craftsmanship probably took longer time, and there were craftsmen who were probably not there, and the schools had kind of disintegrated, and this was the fastest way to construct and put together buildings and the need of the hour at that time. So it was easy to pour concrete than to cut stone or to cut wood. But this now has just percolated, and it has altered the DNA of architecture and construction. Which brings me to this very strong statement. The inability of the modern architect to understand complexities in architecture, the inability to notate it, led to the death of the craft of the building by hand. What I mean by saying is architecture is an art of notation. As long as an architect can notate it, he can build it. So when we were talking about pre-modern architecture, the pre-modernism, we were talking about the master builder and the master craftsman. Gaudi is a prime example towards the end of that era, where he didn't make drawings. He used chain models to understand the catenaries. He kind of put together a system of understanding how the structural forces were distributed, and he worked out with the master craftsman the method of constructing it together. He didn't need to annotate it. He didn't need to put dimensions to it. He didn't need to make drawings of it. And probably a lot of those buildings were made because they were not very detailed drawings or wall sections or systems that were made at that time. As far as the modern architecture is concerned, the need for making drawings, the need for producing 5,000, 10,000 drawings for every building. Look at any project by any of the big firms, take HOK, take SOM, look at the number of drawings that are produced for a single building, not just by the architectural firm, but by even the partners and the vendors and the contractors, the shop drawings. All of these run in thousands and thousands and thousands of drawings. And it comes to a simple fact that if you cannot notate it today, you cannot build it. Having said that, we formulated a firm where somewhere, I think it was an anomaly that was created in my own career when I left Sept, which was a great hangover of modernism in those days. In 99, I'm talking about. I was there in Sept from 93 to 99, and there was a huge, huge hangover of what modernism was. And deconstruction as a movement was also looked down upon in those days. So having come out from that school of thought, I left architecture and went into the events industry for about 2.5, 3 years. Having no knowledge on the event industry and something that was so volatile, so fast, so dynamic, the drawings couldn't have been produced. And we had to produce complex geometries, sets, or pavilions in a matter of days, just like installations, without producing any drawings. And that's where one learned that there is an entire world that exists beyond the notations. There's an entire world that you can create by working. But of course, in architecture, that does not hold good, completely true. So what started off was a thought process in design where we said that let's create or move towards an architecture where we can use technology, we can use craftsmanship, we can combine all of these together and start creating a language or a theory of architecture which is deep-rooted in construction, which is deep-rooted in how it has to be built or the craft of building together, but at the same time exploring newer and newer languages. That's when MOFA or the manifestation of fluid architecture was formed. And this image that you see, it was shot in the office, and it is very important and pertinent to me, because what it means is getting inside the head of the computer, not the other way around. We never believed in the computer getting into our heads, but we always believe, how do you get inside the head of a machine and alter the machine and direct the machine rather than the other way around? And that is a very, very important aspect when we talk about the intuitive and the logical side of the brain. Over a period of time, multiple projects, and the whole firm has been based on work in progress, or a practice which has been practicing newer and newer methods to learn or to come to a language that we could use for the future. I think we're still exploring, and between Anuj and me, we continuously, and between all the other team members, there is Anuj, me, Tanushri, or whoever part of the team is, we keep exploring and talking about what is the language that we're looking for. What is, and it's not an abstraction, it's not an abstract term. Language is something that comes out of construction, something that comes out of what you can build and what you can put together and what is received by people, a habitat that can be put together. So yes, this is something that we have explored, various aspects of it. This is the project that started it all. It's a residence we got to do as a part. When you look at the modern builder housings, and I go back to a reference to Corbusier again in this case, sadly, and however, he had made a reference while designing the city of Brazil that you could literally make a city with 5-meter slabs, 5-meter height slabs, and a 5-meter distance from each other. And you can just give this entire frame structure to people and let them insert their own language of houses within them. And somehow that stuck, that image of this whole bookshelf kind of architecture where there are multiple RCC slabs and there are all kinds of styles from Renaissance to Gothic to various things, houses that are sitting inside these slabs like bookshelves, like books sitting on a bookshelf. We thought that we will take this project, which is part of a builder housing. It is, of course, a frame structure, concrete frame structure, columns, beams, slabs. But let's, within that grid of frame structure, insert something different. And let's start blurring those boundaries of a formal plan. Let's start melting the space. Let's create anomalies within it. Let's start carving spaces in terms of its form, in terms of its edges. And we started translating those planar edges into more distorted grids, into bending walls, into one space moving into another space. Because in an Indian house, you cannot, or rather any house, you cannot define it as living, dining, kitchen, bedroom. There are in-between spaces. There are breakfast spaces. There are spaces where you sit and have tea. So there are these kind of in-between spaces, and we wanted to kind of use that by creating these, by bending and shifting these walls. And of course, the resolution we'll come to. We understood that we have to use a spline and not a line, because every time we were drafting, we were only using lines. Whenever we drafted on CAD, we used lines. But then we started using modern softwares, a newer software that helped us understand the meaning of what is a spline and how to create curves or nerve curves in spaces. Differential geometry, which is not repetitive, a waffle joinery, slicing, space notation, and manual adjustments within that as a first exercise for us to understand how to create these anomalies within this existing space. So right from furniture to walls to pieces, we started inserting as and where, and we started distorting that grid. Idea was to kind of sketch over that definite grid and start blurring those lines. The upper floor, we had various elements, including one of those, a ribbon that you see out here, which starts from the ground floor level and goes all the way up in 3 dimensions, just as a notion that the space is continuous. And how do you annotate an element like this within the space without using a drawing? First wall that was built, which is a doubly curved wall, and we didn't use brick here. It was too restrictive for us. We used plywood. We sliced the wall at various levels at 6 inches. We took 1:1 scale printouts, and it was given to the contractor. He pasted it over the ply, manually cut them, put it together. We ran reinforcement bar services through it, and then putting a shell or a wire mesh with gypsum plaster, we were able to achieve various walls within the house, which would move, shift, bend, ceilings which could be double sliced or waffle ceilings that could create these shapes and forms, even furniture Here, the craftsmanship came in. We used the same slicing structure inside, but we used waste wood, and the carpenters put this together in this beautiful pattern that repeated from a rib to rib, creating these pieces of furniture inside the house. A bed and a table, an entire kids' room that was formulated using the same methodology, but here gypsum plaster was replaced with ferro cement and an epoxy finish on top, resulting into forms and spaces which were moldable, which were, for the first time, we had understood and tried seeing that it is not a linear extension of a plan, but you could look at a space in 3 dimensions and you could sort of mold it together. We could put together a ribbon like this with few XYZ points, and a reinforcement bar was bent as a guide, and we could create elements of these kinds. And this is where we first time understood the difference between annotating on paper or a drawing and how you could create something like this in space. Soon after, we got a project to do, which was a shooting academy in Bhopal. As an inspiration, and somehow this intuitive side of these ideas have always been part of everything that we have done. So if we get a project and we are told that, oh, it's a shooting academy, the first thing that rings in our head, almost like an advertising agency, what is shooting? Is it bullet? Is it gun? Is it motion? Is it going through the space? It creates a force field. It's an impact. Bullet hits something. It creates a force field around it. So what does it do? We said that let's look at a plan where this path of a bullet pushes everything aside when it comes down. Of course, there are bylaws to a game. In sports, you cannot do anything beyond north-south orientation. There's a strong axis you need to follow with a leeway of 5 degrees on either side from the north-south orientation. And that was enough for us to create this entire plan, which from the central axis, shifts 5 degrees on each side. In terms of its resolution, it was the first government project that we were doing. We had no idea what is a government tender, what is SOR, schedule of rates, or how things are put together. And we looked at a complete concrete building. And somewhere, I think, because you're trained to think like a modernist, we were always thinking like modernists. We were always thinking about column, beam, slab, and frame. And this is where he translated that entire form into an RCC frame structure, because even the structural engineer, the entire ecosystem in India and everywhere works pretty much on the factor that most of your structural engineers will tell you it has to be column beam, there are forces, there are earthquake, there are lateral forces, the load has to be transferred, and it's always comes down to a frame structure by the end of it. We failed as a project somewhere. That was the plan. So from the central axis, the 2 galleries, the 50 meter, 25 meter, are shifted 5 degrees, and a connection very seamlessly taken somehow helped in developing of this form where the volumes, the plans were put together as a seamless curve or this sinuous kind of splines on the ground. A corridor which had this kind of symbolism of a bullet cutting through the air, where the air keeps expanding as the bullet moves. And those portal frames of the corridor were conceived to give that notion of bullet moving in space, and somewhere even deflecting to a certain point, ricocheting from one point to another point. Complex construction, RCC beams, RCC columns, complex reinforcements, multiple days on site, and by the end of the first building, contractor, the government, and us, we ran out steam. Looking at this construction, which was, if I look back today, it was a learning, but it was a failure. I mean, if we could do it, we would redo it in a different manner, altogether in a different manner. But having resolved it in this entire RCC structure, we were able to build only one building. And today that shooting academy has been continued by some other architect with some other form in a very different manner, and it's perverted architecture to us. It was a learning. During the same time, we were working on a club in Lucknow, and this was November 2007. Here, now why I'm saying this is because we were trying to draw parallels. We were trying to take learning from one into another. The inspiration here was we were wanting to reinterpret a club as a typology. Club which has been known as a term which comes from the British era, whether it's the Lucknow traditional club or the Delhi Gymkhana. The Gymkhana or the club had this formality of spaces where each space is defined for each function, and keeping in mind the British and the Indian, the locals, there were divisions that were created. We wanted to blur all of that. We wanted to create a seamless kind of connection of functions in this new democratic world, create a club that could be knotted at certain points, these continuous Mobius loops of functions, which were knotted at common function areas in terms of nodes and branches. So we again looked at a spline, we looked at a continuous smooth surface, a differential section, and this is what we came up with as a first model or an idea. Here, multiple loops, multiple functions, there were interrelated functions. So talking about functions which are related to eating, functions which are related to playing, and functions which are related to meeting. For example, the restaurant, cafeterias, and bar versus the play areas like sports, indoor sports, squash, versus the third types, which is meeting like conference rooms, banquet halls, and everything, were distributed as 3 different Mobius strips which interloop with each other, coming to with common points at the knots like kitchens and service areas and back of the house areas. So a very sinuous kind of a design, a plan, which was presented. It was approved also, and we were ready to build this project till the time it reached our structural engineer. And he started resolving it again with the form of grids and plans and RCC and everything. I wish at that time we had used that knowledge of how we had sliced in Aman Bina residence as an interior and probably looked at a new structural system. But the codes and everything, once you don't know your construction, once you don't know your structure codes that well in the beginning of your years, you tend to listen to your structural engineer with complete continuity. What happened was this: that entire form, that entire sinuous continuity, those looping, got lost into this building, which was to us a complete failure. Thankfully, in 2007, end of 2007, the recession had hit, an economic recession, and about 4 of our projects got shelved, in which this was one of them. And I'm very happy that this got shelved and we didn't build this project, because we would have had to live with this project, and it would not have led us to learn something new. 2008, just a year after that, we got an opportunity to do our first installation from this firm called Odyssey, which deals with stone. And they gave a simple brief. They said, we use stone. Can you present stone in its different forms? Can you bend it, mold it, change it, alter it in a way that the perception of stone that people have in their minds, which is a masonry block structure or a cladding, changes, and we can look at something which is more sinuous, something more continuous. And you have an open brief. You have a 5 meter by 5 meter by 5 meter cube. Play within that. Do whatever you want to do within that. We started with the story of stone. We started with a water splash on the stone, or the water splash created by a stone thrown in the water. And we used all these images and these ideas of how a stone ages, how the edges become rounded, they become oblong, they become various shapes, how a stone travels from one point to another point and it changes its form. It bends, it corrodes, it erodes. And that we wanted to create. So we translated, and at the same time, we wanted to come up with a new material. We said, why don't we kind of come up with a hybrid system? Why don't we mount stone over fiberglass and bend it? Why don't we create a surface like a veneer, which is a flexible veneer? And we started testing. We did multiple tests of curves of bending that veneer, at what point it will break. And end of that, we were able to resolve this one installation, which ended up with 3 results. One was an outer skin, which was a modular skin, which was CNC cut and CNC milled. We wanted to use that. A robotic construction, sort of robotic or a mechanical construction, along with the craftsman. We did a table as a product, not a table, but a wash basin, bathtub, and everything. I'm going to show that as a topological optimization, a form which is a sinuous form with soft edges. And we were able to put together for the first time something that could be done using machines and not by hand. We could come up with a skin on the outside, which was a dry cladding, modular, made in a factory, CNC cut and CNC milled, brought here and assembled like a jigsaw puzzle. We could do a flooring, which was not a continuous joints, again, like almost like a puzzle. It could fit in, and each and every piece was calibrated and put together. We could create an inner skin which was far more flexible and which could bend in all the axes and become a 3-dimensional space in itself, and we could do a product which you see inside, which is a single carved product from a single slab of stone, or rather 3 slabs of stone. Multiple drawings. In those days, we would still create drawings, and of course, now the quest is to move towards a space where we can straight away go from design to production without going through this whole process of printing drawings on paper. But some drawings were printed, some drawings went straight away, in this case, from the model to the machine. And the system of how it has to be put together on site, the craftsman putting or inlaying works within those CNC carved stone panels, inner skin, which was resolved, the structure was resolved very similar to Aman Bina with plywood slicing, and the flexible stone was mounted all over it like a skin which ran over. This innovative product of a wash basin, bathtub, and a bench as a was conceived of 3 single blocks of stone. Keeping the time in mind, we did a calculation, and this done on 3 CNC machines, 3 CNC milling machines, which in those days were not available in Delhi. They were only available in places like Jaipur because they would carve jalis and export it out. So they had those machines. It was roughly giving us a time of 6 months to produce these 3 pieces after resolution and putting everything together. So having only a month in front of us, we went back to doing one object, which is just the wash basin, and use the slicing technique of stone. Slice it to a level that each and every layer is done by a 20 mm stone slab, which is water jet cut, organized together. Here we understood a new concept called nesting. To optimize the material, we got from the market the ready-made sizes of the stone slabs available, and we arranged all these pieces that had to come in layers in such a way that we do not waste any stone and we could optimize it. Of course, at that time, it was done manually. All of you know Sushant Verma from that lab. He was an intern that time who was working on this project, and he was somebody who had not started on Rhino in those days, and he started working on Rhino and started understanding that as a software and started understanding how things like these could be put together. And he was able to sort of work together a jig system or a trolley where we could just align all of these pieces together and we could construct and put this piece. This was, of course, a huge learning for us in terms of technology, in terms of construction, in terms of milling. That has now become a norm, something that we use fairly regularly. 2009, we won a competition to do NIF project in Kangra. And the first part of the project was the students' housing, which the site you look at had about 40 meters of drop from top to bottom, almost a 45-degree slope with more than 50 to 60 existing mango trees and banyan trees on site. What we decided as a natural phenomena was not to cut a single tree or even a branch of the tree and maintain the waterways, because there are these interesting hills have their own waterways. And the traditional way of constructing is creating decks or levels, level out the hill, cut and fill to create these terraces and then build on top. What we didn't want to do was exactly that. We didn't want to change the topology of that hill, and we wanted to build on that itself. We mapped it in detail, including the trees and the contours, and we built a 3-dimensional sort of map over it. And what we did here was we subdivided all these contours in this entire surface into a modular cube of 3 meter by 3 meter by 3 meter. This was the first time we started understanding the idea of point cloud, or how a single object or a point could be distributed over a 3-dimensional grid with given circumstances or a given data available. We put all these cubes, and whichever level they came in, of course, at that time, this was done manually. We distributed, we contoured, we developed point system, and each and every cube was copied onto that reference point. Manually, we removed the cubes which needed to come as voids to take in light for the other cubes, as what we call it, the light cubes. We interconnected them with corridors. We created an entire system of these units, which was intuitively, manually worked out in terms of its plan and its framing and its structure, of how it can be an interconnected system, yet each one at a different level. So you would go on these corridors in between, where each house and every unit would be at a different level. Somewhere the inspiration at the back of the head, again, from the villages of Himachal, which are at different level, or the hill villages rather, the language of a small township or a village on a hill with linear planning, where every house sits on a different platform or a level, and the street goes up and down as and where the contour and the natural land is. That is exactly what we wanted to replicate in today's time. And without cutting a single tree, we were able to do this construction because we were not leveling the land. We were building a frame within the existing land. So we could protect the trees with retaining walls. And we ended up with these spaces, which were all at different levels, with these courtyards, which were there with the existing trees. Growing trees like this would have taken us another 10 years, but we had a project on the day of inauguration. This is the photograph. We had these beautifully fully grown trees as a part of the project in the beginning itself. The entire language of units at different levels, the water, drainage, everything worked out according to that during construction. Saving the trees, creating these outdoor spaces, these plinths where students could sit out. You know, it became more of an outdoor space for a design school where still a lot of students spend most of their time outdoors rather than indoors. At that time, we were also, within a year, working on a resort in Manali. And for the site to work on, which is a beautiful site in Nagar, overlooking a valley. And after having dealt with what we were doing with NIFT, we wanted to go a step ahead. We wanted to create a habitat or a building that would not be a building. That was an inspiration from the tectonic collision of forces, something which comes out of the hill itself, like an anthill, something which grows out of the hill, like a rock with a moss over it, almost like a paper which has been thrown, or something that goes through an impact of crushing, how it folds together, creates a cocoon of its kind, receives lights from various folds and ends, is the kind of architecture we were looking for. We based our studies on two few factors. One was the anthropometry, which was what you require. So rather than going for the maximum space required, we went for the minimum space required. How much space you require for sleeping, how much space you require for sitting, eating, standing, and we drew lines around it. Those lines became our initial guidelines to form these sort of spaces, and the habitats and the ridge and valley was created using this, which almost looked like this origami kind of form. Something which was translated like this. Site. First sketch, something that grows out of the hill itself, receives light from various points, like these eyes in the sky, looking at the sky rather, or these formation of 6 pods, which sit like these folded things in between, and these crevices and these valleys in between form their own spaces and their own sense of architecture in between. So a formation of these biomorphic pods, which would also help grow local moss over them. That was the initial idea, and that is what we started with. Plans were developed much, much later. We had rough layouts in terms of what would sit where, but these interiors were done much later after the construction was over. This construction took good 6 to 7 years. We were able to construct only 6 or 7 months in a year because of snow and other factors. But it was a painfully slow construction. The retaining walls in RCC on the ground level. But for the first time, we didn't use concrete for the upper structure. We only used the base because zone 5, making the plinth stronger, and keeping all those factors in mind, we only used RCC for the base. For the pods, we started working with prefabricated frames made in steel, which were fabricated in a factory in Delhi. They were made as full frames, taken to the site, and erected. The time taken to erect these frames was literally just 7 to 10 days. We would finish almost 1 unit in a day. The interconnecting arms also came with cut lengths from the factories, and they were welded. So in a matter of, within the first 1.5 months, we were able to complete the entire steel structure for 6 units. Post that, We got the craftsman from Madhya Pradesh to do ferrocementing on top. The ferrocement shell, which is only a 40 mm thick shell with insulation inside, formed the skin over all these pods. To this part of the project, it was a fairly fast construction. We were able to achieve this entire thing within the first season, within the first 1 year itself. Problem started when we went on the rear side, and I don't know if I have the photographs, but yes, I can come back to the standard frame structure building. And somewhere it's this RCC frame structure which has been a pet peeve for us. That building at the back, which is a 4-floor building, starting from the road level going down, was an RCC frame structure, 4 slabs, and again a folded roof. In this case, we didn't go with a prefab. We started fabricating. We had only part fabricated elements from the factory. The rest, the entire fabrication was done on site. If this first project, this lower part took us about maximum 1.5 years with design on site, this took us about 5 years. So that's the difference between an in-situ construction versus prefab. And we started understanding for the first time that we probably need to look at prefabrication as a language of future. And we cannot afford to every time spend time doing this. Of course, translation of this has taken years. It has taken almost 8 to 9 years for us to understand what is prefabrication and how you can take and create forms or create any kind of architecture that you perceive with ready-made kit of parts produced in a factory. Around the same time, we won a competition to do National Institute of Water Sports. And I've talked about this project a lot of time. The inspiration of this project lies, it was a water sports institute to us. It was, and a lot of people mistake it when I say Institute of Water Sports. They ask me, is it a stadium? No, it's not a stadium. Every sports project is not a stadium. It's an institute which teaches adventure sports, which teaches diving for rescue operations to Navy, to life-saving lifeguards. And it has every operation that surrounds adventure water sports. So here, the idea was to create a building that's almost like a bridge, because firstly, you don't need a building to learn water sports. You need to be in the sea. But the building is required for the formal classes, for administration, for library, for other things. So we wanted to create a building which is almost just like a bridge or a link between the sea and the land. Something that is not a building in itself, something which is just a connection, something which replicates the energy of the sea, its waves, its tension, that disruptive equilibrium we wanted to create. We wanted to create a building that's always in tension. So you walk through the spaces and you feel that you're caught inside this large wave. Either you kind of swim out of that wave or you'll be taken over by that wave. So that energy, that disruptive equilibrium was something that we were aiming for. How do we achieve it? We went through a series of paper models to understand the nature of, and this is something that we had done even during Lucknow Club, to create Mobius loops. Here we created multiple Mobius loops, just endless. And we kept doing these paper models using strips of paper pinned at certain points, and we created this differentiative geometry, which is not repetitive, and a fluid transition from one space to another space. The resolution took years. How to prescritize this entire kind of curve or the sinuous form, to break it down in planes, because it's a government project with restrictive budgets. And we had to construct it with standard government contractors working in the basic methodology of construction. In fact, we were working with conditions where even the cranes or using of mechanical means was not taken as a part of the estimation or the project cost. It was such a low-cost project that we could not have used any mechanical means. The entire roof, which is a 40,000 square feet of area, had to be produced.
Manish, we are at the slide, which is, I don't know if everybody's seeing this, so I thought, let me just, we are where you've got your, what you've written. Are you on any visual?
No, not right.
Not yet.
I'm on the written only. So I'm just talking about it right now, and I'm going to go next to the visual. So we had to kind of break it down, analyze it at various levels. I'm drawing a summary before every project, then I go to it. This was the initial image we started with. A surfer caught inside the wave. These spaces, which fold over you. We did these study models with paper. Pins put in at various points to understand nodes, connections. We drew lines and we modeled it. We modeled it with these sinuous curves and forms which interweaved and went through each other, and using and defining functions within them. This was the entry that went in for the competition. And we were given to build this building based on this. Over the next 1 year or 2 years, we started resolving it in the terms of functions and high-level use of softwares to do multiple simulations of sunlight, of water flows, of various analysis, of even acoustic analysis now. So over these last 8 to 9 years, there have been continuous analysis, codes written, and simulations done to take a part of this construction as a prefabricated construction. Because this is where we started. These were the constraints to us. We had to control costs. The whole project was to be done in 27 crore. And it is about a 1.2 lakh square feet of built-up area with this kind of a form and this kind of a roof and this kind of language. We had to be accurate with our parametric design. Accuracy that we were aiming was plus minus 5 mm. We had to subdivide these large roof into smaller manageable modules that could be lifted by hand and put together with very, very basic scaffolding. So what we did was we started using the scrap steel on site. The RCC was cast, and we started using these reinforcement bars to create, over a 5 meter by 5 meter platform, these smaller modules where every point in that module was a different X, Y, and Z. And plotting X and Y and Z and supporting using temporary reinforcements with tack welds, we were able to achieve the accuracy for each and every small module with its exact cut and everything. Every member, the size of it, the cut of it, the shop drawing was produced in the office using our own algorithms. So we were able to give all these 20 to 25,000 individual members of different sizes and lengths and cuts to its precision to the contractor who just needed to cut those pipes and weld them in this formation. Every piece was numbered, every piece came together. So this is almost not using the machines, not using a prefab, but creating a prefabrication on site itself, taking these modules, putting them together, lifting them by hand using smaller scaffoldings. We were able to put the entire roof together over these years. Multiple rainwater analysis to do the calculation of water, how much of volume, how much of flow, to design gutters for this roof, to create a larger system of how we could collect this rainwater on the site, create these drainages, stormwater drainages, and an entire roof system, which would be a double roof system to distribute the wind pressure that comes from the sea winds and make it completely rainproof by 5-layer of waterproofing. There were a lot of drawings, but there were a lot of drawings that went directly from the computer to the machine. For example, the roof skin itself was made using simple color-coated galvanium sheets, non-corrugated. These sheets are the cheapest material available in the market. And these are the sheets you use for your factory. And everybody knows what a galvanium sheet is, a color-coded galvanium sheet, but we always use the corrugated sheet. The non-corrugated is available in the coil form. Being the cheapest, we were able to pick this material up and create an entire system of these panels, which sit like these diamond-shaped panels, double-folded, by creating valleys and gutters between each panel for the water to go out. So it was from micro to macro distribution of water over a slope. And by creating these simple folds, we were able to create waterproof panels just by the folding of it, where the panels that themselves became completely watertight. Each of these panels were completely produced in a factory in Nasik as a CNC cut and a CNC bent panel. We did not send any or produce any drawings for it. We sent the data directly from the computer to the factory in Nasik, and where it has got cut, bent, and now it's being installed on site. These are some of the photographs of last year. We haven't gone to the site for the last 6 months to be able to get pictures. We do have certain pictures, but yes, these are some of the old photographs. Around the same time in October, so I'm talking about NRWs, which started in 2011 and is continuing till now, is almost towards its completion after almost 9 years of construction. Tony and Guy has a salon in October 2011. We use this as an opportunity to do these interiors, and we keep doing these interiors and these installations in between to understand a language for the future, something that we could use to try and test at a smaller scale that could go at a larger scale in architecture. Inspiration being a free flow hair, tress of hair. You know, when you go to a barber shop, they drape you with a cloth. So we said, why not create an entire thing with a draped cloth or a relationship of a hair and comb? So this whole translation was to do a continuous floor without any partitions, and every division in space was created by these panels or the drape hanging from the ceiling itself. So we wanted to create an endless floor space, but no partitions that would come or divide the space. The space would be divided by these suspended drapes itself. A smooth continuous nerve and an exposed structure. We used a similar method that we used in Aman's house. This is what we started with. We divided them into various nerve curves, sliced them, and the language of it was ultimately these slices which hung from the ceiling. A very similar construction that we had used in Aman Bina residence, but this time we exposed the structure and did not cover it. We exposed it to become the language in itself. And since it had to become a language in itself, it had to be done very neatly, cleanly, and had to be extremely high finished product for an upscale salon of this kind. The entire space, a cross section through it of how each of these comes together. Only in certain areas where we did require for a structural purpose, we added these louvered kind of screens in between, which was almost like a relationship of a comb and hair together. We created a network of ribs on the ceiling from where these could be hung down. So a structural system was worked out where this thing is almost like a false ceiling, which hides all the surfaces inside, yet it's not a ceiling. It forms a space. It comes down, and it forms these spaces or these partitions in between. The first time we actually went down with nesting, which was done using a code, using a command, using a computer. Before this in Odyssey, we had done nesting manually, but by this time we had figured out a computer code or a command that could run and do a job which had taken us days in a matter of an hour or maximum 2 hours. The amount of time a computer took to calculate all these panels were sorted out, nested, put together, and we knew exactly after 3 hours how many plywood pieces are required and what are the cutting patterns of it. So that pattern could go straight away to a water jet cutting machine or a laser cutting machine, and it could be cut directly. And that's exactly what was done for this project. So we were able to produce these ribs much, much faster with interconnecting locking joints, and they hung from the ceiling literally without any joinery or any support that is visible. 2014, we got an opportunity to do this, another installation. And now we wanted to explore the idea of point cloud, which we had started off in NIFT. And we said, let's create a landscape. Let's create a quick landscape, which can be put together in 5 days. And that landscape is something that we can replicate, we can use, and we wanted to use a waste material to do it, a waste filler material rather. So we said, let's take up something like a shipping pallet. It's a waste material. It has got amazing compressive strength. Let's form an entire landscape using these pallets and form shapes which are almost like an earth mount, which is a natural earth mount without filling of a lot of earth. So we wanted to create a cavernous earth mount with an oculus opening on top. And we wanted to create this whole cavernous kind of mound which you can enter and exit at one point. We used slicing, we used point cloud, we used modular stacking, and we used the principle of center of gravity. Our first sketch was something like this. You can think about it on computer, on paper, but you can't build it using a palette. And plus, we also didn't want to create a regular form of this kind. This is the first sketch. From there, we translated the design using 2 cubes, which were twisted, and a space in between. So we said this could become a space where you enter, and these 2 cubes, you could go on both sides and enter and create this network of 2 individual volumes, which finally got resolved into a space like this. So here we used a computer program to distribute these pallets over a point cloud. We were not using Grasshopper in those days. We were using our own Rhino commands. We had Visual Basic, and we had various other there was something called a monkey script or a Rhino script, which was used to distribute these pallets over a point cloud, where every point became the center of this pallet. The interesting thing is, we didn't make a single drawing for this project. What came out ultimately was just an Excel sheet that gave a reference of only one pallet, and from there, X and Y shift of every subsequent pallet in the layers. So we had layer 1, layer 2, layer 3, and so on and so forth, about 45, 50 layers, and each layer had a panel number, which was just an X and Y given on an Excel sheet. So we had 3 team members, each one looking at various sides of this thing, holding an Excel sheet in their hand, and just guiding the person to take and nail a pallet X and Y from its previous pallet. An entire system was put together with a sheet, sulfoline sheet on top, thin layer of soil, not soil, but almost like cocoa peat. There was no mud used in this, no earth used in this to grow grass. And in a matter of 2 days, we were able to grow grass on this entire system. This installation was there for about 4 days. People walked in, used it for coffee and everything. What happened within the first day of this installation was that it rained. What we didn't anticipate was wood, when it takes water, it swells, it becomes heavy. And all these things that you see cantilevered out here started bending down, and the whole structure started twisting and coming down. And the later photographs of this project, which I don't have it right now, has this whole system propped up with multiple wooden props like this that you see out here. And a huge, huge learning for us in terms of understanding the structural behavior, structural optimization, and how to understand and integrate an optimized structure within a whole network of while planning things like these. Each project has been a learning, it has been a success, and it is learning to the next level. Fortunately, at that time, so there is a precedent to this project, why it was also pellet and why it was, there's a relationship between these 2 projects, the Pensieve and Office for Delhi Daredevils. Office for Delhi Daredevils started in January 2014. Pensieve was done in February 2014. We had conceived of a form or a space within the Delhi Daredevils office, which is almost like a cloud that was a reminiscence of the energy in a cricket stadium, splines created by a batsman hitting 4s and 6 all across the field, a bowler that's throwing the ball, and the curves that are formed by it. Formulation of all of that, we wanted to kind of translate that language into this fluid or amorphous cloud that sits within the office, becomes a space, becomes a coffee lounge, and dictates and defines the whole center of the entire office space. We ended up using all the wood from the entire pallets from Pensieve into this. And this is where we, for the first time, after having done point cloud distribution, we were able to distribute it over a complex surface like this, where the internal structure was just done using reinforcement bars. So we had the X and Ys that got created by reinforcement bars, and we had a clamping system of each of these planks, which had an equal distance from each other, and they distributed, creating this beautiful pattern inside. A small movie I'm going to take you through. So the inspirations, swing in a cricket, batsman, bowler, I've talked about it.
Is there an audio to this? We will not be able to hear the audio.
That's okay. There's only music in this. So.
Okay.
This explains very clearly of how a cloud is distributed in points, how points are distributed, taken, the internal structure, the outer structure, using two different methodologies of putting this whole structure together on site. It was, of course, a 3-month project, and it was completed in 3 months. I will skip this part and go to the next project. Another installation, 2017. One of the last installations that we have done till now. No, not the second last installation. The last one was Room of Illusions, where we wanted to explore something new. We wanted to create a language now where we don't have to create a single drawing, number one. Where we could use, now there is this entire concept, which is by now in 2017 had come from the West, of a robotic construction, of a robotic arm that could manage, or machines that could kind of put precisely your modular bricks to modular blocks to cut, weld, various things. The place where we practice, and this is where the craftsman comes in. He's very important to us. He's a very important factor. The brain of the craftsman that has developed over the years, over centuries, within the DNA, has a certain algorithm of how to put together few objects or the things that every craftsman works with. A carpenter knows the joinery. A metal craftsman knows what are the folds and the bends of the metal are. Of course, they learn it over a period of time through generations. But a craftsman, by the end of the day, knows intrinsically or intuitionally what is the feel of that material inside. A stone sculptor knows the vein of the stone or where it's going to crack. And that is where there is a difference between a robot and a craftsman. What we wanted to do was create a machine language, which then would be taken over by a craftsman, and almost working in tandem with each other, they would come up with a system that is a newer system, something that cannot be produced only by hand, only through annotation, and definitely cannot be annotated on paper. You cannot create a drawing of this. So we wanted to do this whole algorithmic system of putting an installation together. The initial studies were, so it was based on various trees of Delhi, how the trees after getting cut, the stubs remain, and those forms of the stubs were abstracted and used. We did multiple clay models to understand the forms, and those clay models were then converted into three-dimensional models. Sushant worked with us again on this for the optimization of the form, and we worked on site for about 8 days, where the entire data from our computer went into a factory where the internal ribs of the internal structure was cut. And on site, then the craftsmen started welding 1-inch metal strips, the scrap metal, which we collected from the waste market again. And they started putting these tack welds in these various forms and manners. So what we realized that these 8 different installations, each one had their own stitching pattern, each one had their own method of rotating, turning these strips from where they came from. So every craftsman was using his own mind to create these multiple algorithms, which we could not have conceived with a single mind. So in a manner of speaking, the whole idea of cobots, where there are robots and there are humans, and both come together in creating this balance of intuition and logic. The largest structure that was put together, structurally, there's something we understood out of this, and that was that plywood, once put at this level, is laterally extremely weak. In fact, wind came in between. There was a storm, and a couple of these arches had fallen down, because by itself, this structure was extremely, extremely weak. But the moment we started tying it with the steel strips, welded them, nailed them all around it, it became a monolithic structure. It became a very, very strong structure. The skin itself, which was literally 0.5 mm thick, became the entire structure strength for the thing itself. So the ribs and the skin both worked in tandem, creating this organic structure, which was extremely strong. And an idea that we are now wanting to use in architecture, where the skin itself becomes the structure. And we have gone away from the grid, from the frame structure, from the modernist cube. And by this time, we had broken the modernist cube completely. There is no cube. There is a global geometry. There is we've created from the cube to this entire form, or this organic form that you can call, Mario Carpo calls it a fish. Anuj was just showing me the lecture the other day, and this whole fish does not have a grid. The grid is missing. And this was a huge revelation for us. We worked on this project last year. Unfortunately, we didn't win the competition. We were working with Bhavna Dandona on this as a conservation architect. We were doing an adaptive reuse of the silk factories in Srinagar, where we wanted to use the same methodology to construct these interconnecting bridges within that project, where we were wanting to use the metal from the old sheeting of those factories, cut them into 1-inch strips, and weave them and build them together, almost like, you know, so a silk embroidery has this adda, a wooden adda, onto which you stretch your cloth and you use a needle and you weave through it. So we got inspired from the form of a cocoon, the skin, which itself would become the structure and would span around, creating this entire bridge, suspended from the top like a needle and a thread, was the inspiration behind all of this. And we could salvage the entire roof material and recycle it into these beautiful new forms. From here, I will shift the presentation to Anuj. And Anuj, unless you want me to change the slides, or you want to change the slides yourself?
No, I think you can keep changing the slides. That's fine.
Okay, just keep telling me. Yeah. So this is the learning. From here now, I'll shift to Anuj, who will talk about the learnings and how we are kind of putting all of this together for the future to come.
So we would have till now realized that we have went back to all the projects that we have done over the years and sort of understood that each of the life of a project can be sort of subdivided into 4 parts of how our office overlooks a project and how we resolve the entire project. The first, and we are also happy to announce that we would be coming up with a masterclass soon, where we would be imparting the knowledge that we have gained over the last 2 decades and whatever we have understood from our mistakes, from our learnings, and from our failures, and how in the Indian context we can still manage to build the so-called non-conventional buildings without any proper grids, without going into the realm of modernism, but moving away from it and looking at the future of architecture in the Indian context. The first module that comes into play is the inspiration, where we talk about the conceptual ideation or the storyboarding of it. This intakes the intuitive or the artistic side of the architect and how he translates how he looks at a project and makes it his own. This is where he develops the concept, and this is the concept that you take from the initial stage and you take it all the way to the end. Manish, if you can change the slide.
Yeah.
So looking or developing a concept could be done in multiple ways, and we will be talking about multiple ways of going about it. And if we can just go through it, so one could be a functional sketch, or we could study something with a paper model, or we could develop something with a clay model, or what we call the so-called architect sketch. This is a sketch by Manish, as he has already explained, for the project Earth, or some other sketches which other architects have done over the years. For example, this is Frank Gehry's sketch for the Guggenheim Museum. This is the winning entry by John Hudson for the Sydney Opera House. So how you can formulate the idea or the concept from multiple things. So as Manish was also saying a lot of times, that the function of the project itself, or the brief, or the bylaws, they come like, it's the interpretation of the architect and how he looks at it and develops his own language. And this is the language we are also trying to develop for us for the foreseeable future. So once this is also to do with about how you build a storyboard of the project itself, and you don't focus only on the initial stages of it, but also go throughout the process. Once we have the basic idea or the ideation of the project has been done, then we start translating that into the digital realm of it, and we start resolving probably some functions, some plans. We go through a lot of iterations to come up with something that makes sense. And we also put up a lot of rules. In this particular case, what is really important is the knowledge of geometry. Manish, if you can just move ahead. The understanding of geometry. Sometimes it's easier for us to sketch, but it becomes really difficult for us to translate them or into the digital realm. For us, it's really important for us to start understanding the geometrical behaviors of how individual geometry is relevant to which particular form. So different types of curves, different types of surface manipulations, geometrical manipulations, what's a B-rep, what's a polysurface. These are some things that we have gone through a lot of things, and we have come up to an idea of how to quickly translate an idea into a digital model, which just showcases what is the intent behind it. And obviously, we also start involving the algorithmic approach of going about it, which Manish has already mentioned, how we keep writing the codes in our office and developing the algorithms which help us define the project in the long term. And the idea in this particular module or this particular phase of the project is to quickly iterate through a lot of processes. So Manish, if you could go to the next page. So if you look at the iterations this is the first development from a paper model direct to a 3D model. And then you keep resolving it, keep iterating it, go from one phase to the other phase. And it keeps developing. It keeps developing, but the main focus is that we keep the rule or the algorithm or the concept always in mind and let that define our progression of the project. This is where we more or less sort of know what we want from the building itself. And from here onwards, we start resolving the stage. We start going into the resolution stage of the process. Obviously, this is not a separate entity, and the lines between translation and resolutions are quite blurred. But we are right now focusing on two different aspects of it. And at this point of time, we try and really have a full-fledged parametric model for us, so that it's easier for us to start iterating a lot of things while still keeping the rule or the concept still in mind. We go through a lot of analysis, and based on the analysis, we do a lot of optimization of a geometry or a form. The idea in this particular case is to start moving away from the intuitive side, but rationalizing your intuition and then using the data to regulate the form.
Also to vet it, yeah, to vet that intuition in certain manner.
Exactly. So there are a couple of analyses that we generally do, and all of it we do from the initial design stages. And we're not calling ourselves experts in these analyses, but these give us some sort of data, form our opinions on this. So for example, we do daylight analysis, we move on to from daylight to solar radiation, to surface runoff, to view analysis, to pedestal simulations, and this defines a lot of stuff that we probably keep as architects. We know that what the orientation of the building should be. We try and maintain all of that, but we don't really figure out what is actually required. Along with the environmental analysis, the other thing that we always keep in mind is the structural resolution or the structural analysis. Again, this comes from a lot of learning from failures of a previous project, that if from the initial stages, we can figure out if the geometry itself can ease our structural forces, then we would like to change or manipulate our geometry slightly so that it's easier for the structure to be resolved or for the structure to be less heavy. So you can do an utilization analysis, you could do a displacement analysis. Manish, you can move on. You can do a shear analysis, or you could do a bending moment. This just lets you know that your structure is essentially weak or strong at what particular point, and which are the areas that you want to focus on so that the geometry could be optimized for that particular bit. Moving on. So the third bit that we also focus a lot is how do you rationalize your geometry or your complex forms into something that is buildable. As Manish was saying, that we had a lot of constraints on site for NIWS project, and for that we had to come up with the fabrication technique which could keep our costs under control. So for that, the easiest thing that we could use, or the easiest machine that we could use while still being true to the form itself, was a 2D plasma cut and fold machine. So for that, we sort of discretized the entire smooth surface of it, so that the deviation from the original surface is not more than, as Manish was pointing out, plus minus 5 mm. And it still gives you the smooth surface to look at, but also it's when you resolve it, it's still planar in its nature. So it's easy to put in a machine, cut it, bend it, put it. So this is how you start resolving your geometry, and then coming up with something that is still fabricatable, and that changes from project to project, from site to site. All conditions differ, whether it's a contractor, whether it's your site, whether the local material what's available. All of this has to go in tandem with each other. Nothing is looked at from a different or in isolation, I would say. Now the fourth bit, which is when we know what we want, we have the model which we have resolved to the great extent in the digital realm, but now it's time for it to get manifested in physical reality. This is where we try, and now this is something that we are moving towards, which is essentially drawingless architecture or printless architecture. But even when there are situations where we do need to print, how we have developed our methodologies so that it's easier for us to start annotating drawings, and also to start retrieving data for these complex geometries, so that it's still easier for us to annotate exact dimensions of every point on the surface. So if we move on, this is actually a very good, NIWS is actually a very good example of that. As Manish was pointing out, that we had to break down each of those members into manageable members by hand, since we did not have a crane. So we had the limitations, and because of that limitation, the number of modules went out to be more than 5,000 members, which were going to be fabricated by hand on site. For that, we had to produce 5,000 drawings. If we had started labeling or drawing all of these by hand, it would take a lot of time for us to do. So we set up a rule of what we needed from each drawing, and we let our algorithms generate the entire thing in about a week for us. Also, coming to rules and how these algorithms or the algorithmic thinking helps in resolving complex bits. The entire curvilinear roof of NIWS, it's made up of all differential geometries. No two panels are equal alike, but they still need to be fabricated. And if we start doing these things by hand, it would take ages to do so. So we set up the rule, we let our algorithms generate these drawings for us, and then these drawings, so in this particular case, we had about 2,500 panels to be generated. Manish, if you go to the next slide. And all of these slight variations were developed within a couple of weeks. And these were gone directly from file to factory without a single drawing being produced for these. So the idea is to start retrieving these data or this fabrication data from your resolved model in whichever form it's relevant in terms of your project. So this is I think this is for Urbanscape, where we had to go again from file to factory straight. No prints, nothing required. Resolve it, put it on a sheet, and send it to the factory. Also, the accuracy that we need. So retrieval of the exact dimensions or retrieval of, so if you notice in this particular drawing, none of this is rounded off. Generally, we have a tendency when we are labeling stuff or when we want the mason to start working on it, everything's rounded off to whether in tens or in fives, multiple of fives. But in this particular case, we kept everything to whatever it was. We did not round off stuff because we needed the plus minus 5 mm accuracy throughout the roof. So this is something that we have developed over the years, our methodology of working. And this is something that we feel that it's time for us to give back to the architectural community in India so that we do not still get stuck with the modernism approach of architecture, but start developing our own language of architecture, and the tools cannot be the limitation for that. Just to rewind all of it, or just to reiterate, inspiration is something that makes the architecture your own. That is your individualistic approach of architecture. The translation and resolution, they go hand in hand. They cannot be looked at in separate entities, because while you're resolving the environmental or the structure, your translation will also, it's a loop, it's a cyclic loop till you resolve this entire thing. And once we have done all of that, then we go to the manifestation stage. So these are essentially the 4 modules that we have divided our practice into. And this is something that, Manish, if you would like to add something here.
Yeah. So I'll stop sharing the screen. I think presentation is, you can go back to, long presentation for all of us. And I hope you were able to still keep the audience in bay and they did not leave out for coffee and other things. But yes, as Anuj rightly put together, we are wanting to come out soon, and we are starting within a month's time. Can you hear me?
Yeah, I said we are right here. Don't worry.
Wonderful. Yeah. So we are starting our master classes in about a month's time. By mid-July or something, we'll be announcing the dates, which are open for all young professionals, even professors, anybody who wants to understand this whole drawingless architecture or our learnings from our various projects and the tools and methodologies required. We've divided them into various modules. We've divided them on weekly classes. For professionals, the classes, I think Anuj, we are keeping it over the weekends so that they can look at it. So it's a once in a week class, which would be of probably 2 hours or 3 hours, with exercises given so that you can kind of train yourself into this whole method, starting in all the 4 modules. And of course, each module can be taken individually, or you could take up all the 4 modules together, depending on which part you want to learn and which part you want to understand. So having said that, I think the floor is open for discussion, and we are ready to take
There are a
any
bunch of questions,
Sure.
Anish and Anuj.
Throw it.
There is something that one is saying, do you face problems in communicating the different dynamics of your design to the client? Or do they know what you do and they are already convinced and then they approach you? 1, 2, does this need demonstration? Are there time and budgetary constraints? So that's 3 parts of the same question.
That's okay. I think there's a single answer for that question. And I've been asked this question multiple times, and the crux of that question is, how do you get clients to do stuff like this? That's the crux of it. Or, how do clients believe in doing stuff like this? Yes, we end up doing only 1 out of 10 projects. But there is a certain belief, there is a certain way of looking at things. And I think if you are convinced with what you want to do, it's easier to convince the other person. A client feels more confident when you know what you're wanting to do and when you know exactly what is in your mind. And that is something that as a journey we have gone through. We've been so clear in our head that this is what we want to put together. This is what we want to put ahead. The clients have believed in us. First time when a client like Aman, who came to us and we said that we wanted to try something like this as an idea, we were just having a lot of times we have these discussions which are just open-ended discussions which don't talk about design and architecture, but talk about the philosophy or talk about the psyche and talk about the fact that what if we were to do something like this? And he was very open. He says, why don't we try it out? He let us try. He said, I give you an open hand, you try out whatever you want to do. There is, of course, a budget. Always. There's always a budget to a project. There's no project that goes without a budget. And in most of the cases, budgets have been much, much tighter than what they have been. Budget is the same. It's the same cubist, modernist budget that is given to us based on SORs and plinth area rates, or a standard market rate, or build the project in 2,500 rupees a square foot. It is for us to optimize and work together, as Anuj keeps saying, to build within that. Yeah, Anuj, you want to add?
Also, just a slight thing. That's what we have been focusing so much on. If you know what you want to build, then keeping budgets in control is easier. If you just have a vague idea of what you want to build, but you don't know how it's going to be constructed or fabricated, that's where you generally fall into the situation where you cannot keep the budget under control. That's why so much of emphasis we are trying to give to the architectural geometry, which is actually lost in our education system.
And something that we want to do, we want to go back to the master builder model. We want architects to start, if not building together, at least know how it has to be built, at least know every bit of it, of how to put together this building. Every architect, every architecture student should know that. It is not only talking about things on paper. Architecture is no longer just the modernist idea of, you know, light and ventilation and certain form and certain axis and all those words that we keep talking about. They are important. But at the same time, it is extremely, extremely important to know, like a master builder of the past, of how to put a building together. And that is the language of future we're wanting to turn towards. In fact, we're working on a couple of houses. One house we're working, which is a completely prefabricated house, 7 floors in Delhi, smallest house, 160 square meter of plot area at a lowest budget of 2.5 to 3 crores all in all. And since we know that this is the budget, we work backwards from it. And you'll be surprised to know that doing a prefab methodology, there are no wastage of resources. There are no wastage on the contractor's part in terms of overcoating or undercoating. Everybody knows precisely what they're building and what they're coating for. So there is a huge, huge cost control in doing that methodology. So we're able to optimize cost that way. Can't hear you.
You're on mute, Arna.
Sorry. I'm saying I'm going to take a very leftist side and very, I want to tell. So, are you proposing? We have one of the highest human capital. What do you propose for them? And our construction industry really employs a lot of them. Stop. Before I move on, before I give the mic back to you. So, what about things like sustainability and transportation and procurement of materials? How do we think about that? And then I'll come to the other question. I've just kept it aside. That's Purva's asking. That we'll take it up after this. So over to you both.
Which question you want me to answer? The leftist question or the normal question first?
The leftist question, and then the sustainability and the transportation and procurement of material.
Of course.
Yeah.
Aruna,
you
have seen what has happened in the last 3 to 4 months in this country. You've seen the migrant labor going back to their villages. To us, that was a good thing that they went back to their villages. It is high time that the exploitation of that labor, of that unskilled labor that was happening in the cities, the pathetic conditions they were staying in that construction methodology, they were unskilled labor. We've seen on-site people who do not know how to put shuttering together or how to pour concrete or how to do this, working at the bare minimum cost, living in the most pathetic conditions, have finally gone back to their villages and are probably going to take up agriculture. And I'm happy that they will take up agriculture and go away from the building industry. Only those who belong to the building industry, who know the craft of construction, will stay back and will always be there. And that is what we are looking for. We're looking at craftsmen. We're looking at people who can build rather than people who can just carry bricks or people who are just, dying or going through that whole. And I'm going to answer in a leftist manner itself. There is an entire generation of people who go unnoticed. They're almost like ants getting crushed on the construction sites, and we've all seen that. Hundreds and hundreds of laborers. I think if I feel for them, and I do when it comes down to it, they all have gone back to where they belong to. And that is, I think, a good thing. Mechanization in this industry was a highly needed, and it was a need of the hour. And finally, we are moving towards mechanization. And this whole turn of what has happened in the last 4 months, I'm hoping will give a huge twist and turning this industry into a mechanized industry. Coming back to sustainability, none of our projects are unsustainable. The materials that we use, to the finishing materials, to the analysis, to the environment, to everything that we do. In fact, we go one step ahead and we are producing buildings which can generate their own electricity, which have zero carbon footprint, which have positive energy footprints rather than negative energy footprints. We are working towards that because since we know beforehand through our analysis what we are doing, we are able to foresee all of that and we are able to create a highly sustainable model. And most of our projects use materials which are all locally available, are locally sourced. And if you take steel, steel is of course available everywhere. If we use stone, we use local stone that's available in that area. And over the years, we realized that stone is really not a sustainable material to use because once you deplete a stone from the hill, it never goes back. So it's not really a very sustainable material. Wood, yes, wood only that is environmentally grown for the purpose of construction, which is not very common in India, but in the West. So that's not our material. Material that we can use is optimized use of concrete. Concrete in situ is terrible because it produces a lot of waste. But concrete as a prefab optimized thin shell is still something that uses the bare minimum amount of that material without creating a carbon footprint on site. These are the aspects that we are looking onto. The house that we are building right now is something that can be put together in 3 months and something that will answer the huge demand that is there right now for the housing in this country. A house that over a period of time can be put together by people. It's literally house in a box. And you could, though, you know how much time it takes to build a house in a city like Delhi? Between 2 to 3 years. In situ construction, municipal bylaws, a person coming and taking bribe every month to let you construct the building. It's a huge cost, all borne by the client. Of course, we know that ye to hota hi hai, so we put that money aside. What if we are able to save that money? If you build in 3 months to 4 months, the whole house comes from the factory. There's no in situ construction. You have reduced the environmental load. You've reduced the extra money that exchanges hands, in these kind of matters, and you made the entire construction into a more cleaner construction that is needed to be.
And obviously our motto of optimization, optimization, and optimization. So if you if you use less material, you automatically are much more sustainable than what you would be if you do not optimize your structure at all.
We produce food that every grain of rice can be consumed and not a single grain is thrown away like waste food. That's how we treat architecture right now.
So reduce is the first word. I think so. You people are actually talking about that, and that's quite commendable. Before we really want to bring this conversation back towards what the faculty needs to do, or what do you think needs to happen in the schools? Before that, I'll just put forth Purva's question, like what types of failures that you witnessed were. I mean, it's kind of complicated. So what were the particular failures that you witnessed? Chalo, let's keep it simple.
Don't fall back into the modernist cube every time. Don't fall into the trap of the modernist cube because it's a trap that will never let you leave it.
She was talking about structural failures, by the way.
Thankfully, we've never faced any structural
I don't think we have had any structural failures.
Ever.
Yeah. So we believe you because both of you were not shaking your head. So obviously, it's like, asking the same question in different rooms. So we believe you here. Okay. Yeah. And very impressive work. And something that by Dr. S.P. Anchuri is asking is whether you have used 3D printing or what are your viewpoints on that?
Anuj.
We have a 3D printer in our office, and how we use, basically, the idea is that before we send out anything to be fabricated, we first do a mock-up or a prototype of it in the office with our 3D printer. We detail out everything in physical objects, and once we have the prototypes in whatever scale, 1:10 scale, 1:20 scale, once they work, then it's very easy for us to be very sure of whether it works, and then it can be sent out to actual people to fabricate or construct.
In fact, the last house that we were doing, which is a completely prefab, we printed every component of that house, including its joinery and scaled down joineries, all of them. and saw how it could be fabricated and how the complex junctions could come together. So yes, we have now started 3D printing a lot of our prototypes before we send it out to the factory to test them.
But do you see a foreseeable, I mean, a future? Do you see a future for actually 3D printing? It has been done in different parts of the
3D
world.
printing is a very wide-based term, Aruna. 3D printing
Yeah.
on site in situ versus 3D printing in the factory are two different terms. What we are aiming
Okay.
toward is a factory production. We are wanting to reduce load on site as much as possible. Because bringing a 3D printer to the site, yes, it works beautifully well in a YouTube video thrown in by China. But does it work in real terms of your tight streets and tight roads and your traffic and everything? Can a 3D printer can it be set up in the tight urban scenarios of Delhi, and can you print it? Is a big practical question mark. So we are not pushing towards site construction. We are pushing towards off-the-site construction, because that is what we see a foreseeable future in the industry of architecture.
I think the one of the really interesting things was the YouTube video that you had shared. It was on your Facebook. I think you've not shared that. Maybe you can share the link over here and let the participants see what you were talking about in terms of fabrication of a house. I think it is the same house, maybe,
Yes.
that
yes,
you're talking about.
Yes.
Yeah.
Yes. Yes.
Yeah. So, acha,
I just
besides
dropped the
that,
link.
what do you think?
Sorry,
Yeah,
I
yeah.
was saying, Aruna, bring the discussion back to the core.
Yes, exactly.
Thank you.
There are lots of faculty over here. So let's bring the discussion to what do you think, where do you think we need to bring in? What do you think we need to bring into the schools?
I think firstly slight change, and no offense to any faculty and no offense to any teaching system, a change in the thinking itself. I think somewhere one has to start believing outside the modernist cube. One has to stop glorifying modernism. And I'm saying purely from my perspective, from the school that I came from, where exposed concrete and modernism was so glorified that there was no scope for any kind of newer thinking. I think that is where the start needs to be made. To think that, and probably go back, and I attribute a lot to the people who talk about conservation architects, because they're always dealing with buildings of the past. Both Anuj and I keep discussing this, that somewhere in the last 100 years, we went wrong somewhere. When we started, instead of crafting, we started pouring. We started molding. And that was a wrong step in the history of architecture. Wrong, right, I'm not nobody to judge, but something that stagnated the entire process of learning, of giving back and forth between a master craftsman and the designer. That whole process became stagnated, and it just became a political negotiation between an architect and a contractor and a client that was restricted between the cost of shuttering and pouring of concrete. I think we need to step out of that. We need to step out of these grids. That is a start. And then, of course, skill levels of learning softwares, learning technology, keeping abreast with that certain thing. Unless you have a thinking that is that thinks in this manner, you cannot adapt to a software. Software is just a tool. Computer is just a tool, bottom line. But to be able to think in this direction is extremely important, and probably the start will have to be made from first year itself, where rather than every time looking at showing a piloti to a student, one needs to show how Gaudi's architecture is built and how architecture is built without architects. There's a book called Architecture Without Architects. I think that is a must in every architecture college. I think that should become the first module itself, to analyze those structures, to understand how those traditional structures were built of each and every. Take up the entire book, the entire batch can take up the whole book and take one chapter or a house from there or one photograph and analyze how those structures were built. I think that's the start.
I think that's very interesting. This is something which through the day, in fact, today has been a day of really, dismantling our curriculum or syllabus that we follow. And we also follow. Sushant also follows that. And that you're right about the modernist approach, because if you see our construction syllabus, it starts with brick and then it goes on to, we are doing timber, we look at steel, we look at concrete, and then we say, bhai, bahut sare hain material, but hum itna hi kara sakte hain. So I think that's a big learning out there, that what is the premise we start with? Besides the leftist comments that have come eventually, is there? I would want other people to talk about.
I don't know. I would also like to add that there are only 4 meches that are followed in every school for construction. There is a world beyond meches. I think we no longer follow only Flemish and English bonds. There are variable bonds which are being followed now in brick itself. There is an entire reign of construction, and the world is filled with it right now, where you do not follow the meche construction methods. There are more books required apart from meche in every college.
Absolutely, we are not doing an argument there. We've ourselves had so Bhavna today really spoke about the different Lakori bricks, and Aarti was there yesterday. She is from Pradeep Sachdeva's studio, so she was shift. Yeah. So so anyway, we are not in argument here. We are in contemplation. So let's. Anybody else? Amrita, do you have any more questions?
I did put my questions over here, and I think Manish has. It's been addressed in a way. So I was talking about through the projects. There seems to be. It didn't come across the consideration of the environment. You're talking forms essentially. You're talking about. So what is that correlation between talking environment in terms of physical, contextual, social, human, and how those forms are, that manipulation of form responds to these entities, and is it generated out of those entities, or it is generated as pure form making and installs itself on these entities? Just some thoughts on that.
Amrita, I would ask you a counter question. What did you perceive it? Was it a form that came across, or was it a form that comes out of a generative process throughout the presentation? It's an important thing. Our designs over the years have been perceived like an elephant in the room by 5 blind men. Everybody sees what they like to see and they want to see out of our projects. That is not important. If a lot of people perceive our projects as form, it is fine. But if you take a NIFT project, the hostels itself, the form is just 200 cubes which are generated over a terrain. There is no form. It comes from the psyche of using spaces. Would you go and tell a villager that, grid, you level your entire land, level your entire hill, I'll put a grid onto it, and you start staying in this entire city, which is like a grid? He would probably, laugh at our faces. He's like, you do not understand how I live. So the idea here was to understand the human psyche of how people live on hills, and how you could use that terrain to manipulate that entire data and come together with this whole network of houses, network of cube, which collectively create a form. Or for that matter, even NRWS. Yes, NRWS is a wave form. But bottom line is that there are functional aspects which overlap. Something that we talked about in Lucknow Club, that there are continuous functional loops, and no institution works in isolation. You do not go from one space to another. You cross a lot of spaces in between. So the idea here was to create those functional loops which are knotted at points. So our designs, maybe what is visible is the form, but if you go down to the plans and you start analyzing the interconnections and how these things are there, you would realize that most of these forms are actually generated out of the need of how people use them, the context that we are sitting on, the environment that they're doing, or for that matter, the NIFT hostels, the entire water flow is not disrupted. The trees are not disruptive. Tell me which project on a hill you would build a large housing like this without cutting a single tree or even a branch of a single tree. Here, we did not even disturb the root system or the branch of the tree.
So,
That's environment to us. That's environment.
I appreciate what you're saying. I don't doubt it.
Yeah.
I appreciate what you're saying, and I don't doubt it. My question was simply from the fact that when you were explaining or you're going through your projects,
yes,
you were essentially focusing on the formal manipulation.
Yes.
You have not brought those cues
Yes.
to us.
Yes.
So I can't see those cues. If you mentioned in passing that the levels were used, but what are your other cues?
Yeah. We would
Just
probably
that.
need we would probably need a 500-page book to explain what we are saying. a 1 hour presentation is nothing. It's just a trailer of what we're trying to do. And probably, Anuj, that's a good idea. We should start putting a book together of 500 pages. And we should
Yeah,
start
let's do
talking
that.
about all of these aspects, because this whole talk should be a learning for us to take it forward and into talking about it more in detail of what we wanted to do.
Absolutely. And there's a Garima is asking a question as to, and this is a fact. How do you cope? How does one cope with new software? As soon as one gets comfortable with one software, there seems to be another one. There's a new software. There's a new kid on the block, and there's like this new restaurant that has
I
opened.
can relate to that. I can relate to that. Totally.
And it is so you can relate because so yeah.
I started my architecture, Aruna, when there was no computer. We were doing hand drafted drawings. I come from a generation where entire Sept was only doing hand drafted drawings. I didn't know AutoCAD when I left college. I hadn't used a computer except for typing some words on Microsoft Word or using a paintbrush. That's all that I knew about the computer. But from there, one learned 3ds Max, one learned ArchiCAD, one learned Revit, one learned Rhino, one learned Grasshopper, one learned multiple softwares one after the other. I think what is important is the way you think. That is more important than using a software. And I think Anuj would be a better person to answer this, because he is somebody who's an expert with each and every. He's the one who figures out every new software in the app that comes into the industry, and we start learning from there. So yeah, Anuj, on to you.
I think it's a very interesting question, and I think it has a very simple answer. If you start learning commands of a software, you will never ever be able to cope up with the new softwares that are coming out. The idea is to understand the underlying principles of the software. So, for example, if there is a software which focuses on the nerve modeling bit of it, if you understand what a nerve is, or what a spline is, or how it can be manipulated, then it doesn't matter whether it's software A, software B, software C, or software D. If you know what mesh manipulation is, or intrinsic properties of a mesh and its manipulation, then again, it doesn't matter whether it's software A, B, C, or D. You know the principles of how it's going to behave. Then it's only a matter of figuring out which command is going to do that for you. You already know what you want from the software, and you're just figuring out which command to use for that. But you have to know the underlying principles of it. That's where I think we focus on. We know what we need from the software, and then we use that. And in today's world, I think the internet has a plethora of questions asked, answered, sorted. If you have a question, I'm quite sure that you are not the first person to figure out that problem or to come in that problem. Somebody has been in that problem, somebody has asked that question, and the other person around the world has answered it for him. So it's no point reinventing the wheel all over again. If somebody has already done that process, learn from him and then move on. I think that's our philosophy on learning new softwares. And I think, as Manish rightly put, that I think we learn softwares what in like max 10 days.
Yeah, that's what we do. We keep moving from one to another because we get bored of one software.
Oh, so we've reached that stage. So I think there's Abhay Narkar has written, I think what Manish says was fab. It's the way you think, software comes second. Garima saying interesting takeaway. Thank you, Manish and Anuj. And Anuj elaborating the same very well. So that's, I think what one is also, maybe, and I think that's a fault of the institutions. We really need to kind of get excited by software as well. I think there's something that we need is, so maybe we need to call you guys more often to our college. And
or join our master classes.
Or we can join. Good evening, Dr. Vibhuti is here.
I have been here throughout. Completely riveting. Absolutely riveted by the conversations and all the projects that Manish and Anuj have so generously showed us. And the engagement with what they do and the passion has certainly come through. So we're very grateful for you to spend this time with us. It's really special. I just have two questions, not really questions. These are sort of points of inspiration that the faculty and students will probably benefit from. One is, what you keep repeating the word master craftsman. Who is this master craftsman? He or she even. Who is this master crafts person who keeps featuring in your design process, and you keep talking about this person? What does he look? Not look. What is his back?
It's a wonderful question, Dr. Vibhuti. Thank you.
Yeah.
I think somebody had to ask this question, and it had to come from somebody like you, who is so adept with the traditional systems and has written a couple of books. I think that question is a wonderful question. And to answer you correctly and very honestly, maybe the master craftsman is a figment of our imagination. It's this kind of dream of the past that we keep looking at. It's this golden period that we keep looking at that could do so much more than what a modernist architect did. Somebody that could construct complex geometries in those mosques of Iran, or those Baulis in India, or the step wells of India. It is this collective group of people that could put things together. And we don't know if there was one person, he, she, them, what it was, but it was that collective thinking. To us, this fictional character, this superhero who could put all of these things together, is the master craftsman. It is probably just a figment of our imagination, and we are wanting to achieve that. It's the Nietzsche's notion of a Superman. It is something that we want to achieve, we want to become, and we are striving towards that. So it's probably just that, nothing else.
So do you think the bit of the educational process ought to go towards that, towards
Yes.
the learning
Yes.
with the ustad and doing the riyaz, and that's what actually architectural education ought to be, rather than being in a studio making drawings?
Yes, absolutely. I think students need to start building with their hands, and more than often, the curriculum need not be just 10 projects in 10 semesters. It could literally be 4 projects in 10 semesters, and taking one project into construction in the next semester and build a part of it. Bauhaus School started off wonderfully for the modernists, but it stopped only for the modernists. I think what we need to do is recreate multiple schools in various parts which talk about construction using hand, maybe using robots, maybe machines, maybe softwares, maybe working with the craftsmen. Maybe a school could be put up, a workshop or a summer school could be put up in a village where there are craftsmen who are staying. Even today, one could go to places where the clay casting happens, or Muradabad where the metal work happens, and a whole school, a temporary school is set up for a month out there, where you work, you write algorithms, you write things, and you work with those guys with computers. So for all you know. Yeah, Anuj.
I think another point that probably we can start thinking about is collaboration, which and moving away from the idea of the architect as the one person who's it.
Yeah.
Like now we have to move to a situation where it's collaboration. Like everybody knows something or the other. If you're ready to learn from the other person, then your project's only going to become better.
Yes, Dr. Vibhuti, we want to kind of dissolve that notion of a one man being an architect. We've been striving for 20 years to not create a single figure who's an architect, but to create a collaborative, collective group of people that can think simultaneously. And in fact, I would like to request to you, and Sushant School being a very modern and forward-thinking school, we're wanting to do an installation soon, another installation, where we're wanting to explore newer methods of construction technologies. Would you be open to send in 20 or 30 of your best students to build that installation along with us, to learn with us, to work with us, to come up with something new, which you can document as a college, and we can learn and go from one installation to another installation and understand how construction can be done. Would you be open to something like that? Yeah, you're on mute. You're on mute. Sorry. You're on mute.
You're on mute.
You're on mute, Dr. Vibhuti.
Absolutely. I will be more than willing. And tell us when.
Yes, we will. Since we now know that we can get your support, we can come up and think about some installation.
No. Absolutely. There are ways of doing it. There are ways of embedding it in the curriculum. There are ways of embedding it in timetable. We have a lot of, malleable tracks. Like we have an elective track which you could run, which is part of the projects. We also have the summer chunk. We also have so absolutely tell us when to send them, and I'm sure there are lots of keen young spirits wanting to work with you. It will be a treat.
In fact, Anuj, that would be a great idea. We can do an installation at Sushant School itself. You know, the space is available, and if the students are there, maybe we could go and conduct a workshop where we could put up something together and test new models. You know, with the students.
Absolutely. Use this as a thinking lab
Yeah,
and a making lab.
Yeah, we would of course
No,
demand your best
absolutely.
student for it. Because we are high disciplinarians. When we look at, we really train. We are like kung fu masters. We don't spare.
Yeah. So they're all good. They're all good. I mean, some need more coaxing than others. So
yes, I'm sure. Yes.
The other thing I would like to ask you is, so where, obviously within your own journey, you've been raising the bar after each project. You've been trying something new in terms of, the very strong concepts you have, and also kind of, whether it's new material, whether it's new process, whether it's new concept. So what's next? So where do you raise the bar, and who are the people in the world you admire? Like you sort of, there are always these stars you look up to. Well, but in your case, you are the star for us. But are there people who you kind of think, okay, that guy is doing interesting work, maybe we'll do something like that in India? I mean, are there, few examples?
Anuj will give the names. I think we are all starstruck people, and we also have our own stars that we follow. So Anuj will give those names.
Tell us.
I think I personally am really interested in the work that's being done in the block research group at ETIA. They are doing something which is something wonderful. So I think you guys can look at. So it's essentially done by Philip Block. He runs the entire program, and he takes. I mean, he has a lot of subsets under BRG, which I think. Rather than me explaining, now that I've introduced,
you should look at YouTube videos. You could look at Philip Yuan. You could look at these guys.
Philip Yuan from Collaborative Laboratory. Yeah.
And Anuj, who's done that? Nit Candela. So you could look at.
That's again BRG and Shajay Bhushan together. They've done so. ZH Code and BRG. They've come up together to do an installation in which was done in Mexico City. Which is another wonderful, like these days, I think they are pushing the boundaries, and I think we are still a long way from there, but that's where we are.
Vibhuti, to tell you about Nit Candela, they were able to put together a stitching pattern for a shuttering, which was a cloth stretched with tension cables. That cloth was just 500 kilos, packed in boxes, taken on a flight, stretched on the side, and sprayed with concrete to come up with a concrete shell without any shuttering. So it was fabric that was stitched and woven in a certain manner, and the entire code was written on the computer for it. So that's the kind of stuff we're talking about in future. Yeah, there is lots that can be done.
I mean, there are lots. There are endless. And
do you see
definitely we would have all of that.
Sorry.
Yeah. And do you see some kind of marrying between, traditional processes and your techniques? For example, Rajiv was talking about, he did an elective called Anonymous Design with Sushant School, where he looked at, with students, of course. And one of the students and him, they came up with this idea of a whole building woven like a carpet. So you use the knotting techniques that the craftsmen use to weave a carpet, and you kind of weave a three-dimensional. You use the same underlying mathematical.
Exactly. That is what we're aiming for. That is exactly what the future for us in design lies. The traditional techniques of the craftsmen marrying with the computational algorithms. That is something that we are looking for. That is the image of the master craftsman of the future that we have.
Excellent.
And I think the benefit that we have right now, as just because the computers today are so powerful, so essentially any craftsman practices a craft without having a formal knowledge of it. But he learns about all of it by just going through iteration and iteration and iteration. Learns from his failures and perfects his craft. With the use of computers today, you can essentially iterate through all the work in about an art that probably a craftsman would do in his lifetime.
So you could actually have a
So,
machine knowledge of 100 craftsmen together into a single program and use their collective knowledge into a single algorithm.
And what's
I mean, we're not,
what's-
no way saying that craftsmen should be eliminated. No way we are saying that. Again, so the collaborative process of it again comes together. Learn from it, simulate it, iterate it, and then get the masters to do it for you.
I was going to say, what's the hurry? But of course, the hurry is that, you know, there are lots of homeless people. You need to build rapidly, you know, housing, and, you know, there's a lot of need for that speed, which you bring in the processes without compromising on quality, which is a fantastic. It's a combination. Usually, what happens is you rush the project, and, you know, the quality comes down. But in your case, it's.
I mean, we've seen these mass housings being done like factory sheds, and they are horrible. They're like concentration camps. They look terrible. They feel terrible. They work terribly. They have no feel. What we are aiming towards is something that is more humane, something that is aesthetically pleasing, something that you could live with, but could be mass produced in a very, very short period of time. That is what we are aiming for.
Excellent. Thank you. Thank you for responding. Thank you. And look forward to the collaboration you just mentioned.
We would get back to you very soon on that.
Absolutely. Please do. Look forward.
Thank you. Thank you so much. Thank you so much, Aruna. Thank you so much, Amrita. And Dr.
Thank you.
Thanks.
Thank you so
I'm
much.
wondering if any student has any questions. Any student? We've got a couple here, a few here. If not, we'll close. I think they are a little overwhelmed, maybe.
Maybe you, Manish
Hope
and
not.
Anuj, you can post those links you were talking about. Maybe something you want to. So
I think Sydney has already posted one of the links, and the YouTube link I've already posted, so you can look at that if you want.
Yeah.
okay, fair enough.
right.
Thank you. Yeah, we have. It's been a really interesting session and lots to think about. And maybe, you know, Vibhuti, when we are thinking of getting Mohanji, we should get Manish and Anuj also. You know, really get all of them together and
do
you know, in the same.
and do a collision. Yeah.
Yes.
Yeah. Let's do a collision. That is fabulous.
And the new master craftsman out of it.
Yeah,
Hoping.
let's identify. Yeah. So thanks a lot for this, and let's look forward to future collaborations. And thank you. I think so. Thank you from our participant sides also for being here. Such great attendees. Everybody's been with us. We've had a rigorous week, and we have a closing half day tomorrow. We have Dr. Hussein back with us, coming with his international. He's going to bring international best practices. Sorry, now even I'm fumbling for words. Yeah, and we'll have Professor Ashok Lal, and we'll have, of course, Vibhuti will be there with us, of course, and for the final day. Thanks a lot.
Thank you.
Everybody.
Bye. Good evening.
Thank you so much.